Hello, I'm Farnaz Jahanbakhsh, and I'll be presenting the work An Experimental Study of Bias in Platform Worker Ratings, the Role of Performance Quality in Gender. This is a work I did along with my collaborators, Justin Cranshaw, Scott Counts, Walter Lasecki, and Kori Inkpen, when I was an intern at Microsoft Research. Online platforms such as Uber and Upwork are the source of employment, sometimes primary employment for many people. These platforms often solicit ratings of their workers' performance from employers based on the service that the workers provide. And these ratings are then used in a variety of ways that affects workers' livelihoods. They're used by platforms to determine how to manage their workforce, for example, by banning workers whose ratings are below a certain threshold from the platform. They're used by the platform's algorithm to rank the workers, and as has been reported in prior work, ratings affects workers' probability of getting hired and their future earnings. But since ratings are by nature subjective, they can embed societal biases that disproportionately harm or favor certain demographics. These demographics biases could manifest differently at different performance levels. It could be that raters are influenced by such biases only when their employed worker is not performing well, and rate them lower if they belong to certain demographics. It is also possible the biases incorporated in the ratings are perpetuated by social influence and herding behavior, and that prior possibly biased ratings influence the ratings of future raters. And these are the issues we're investigating in this work. Our work aims to answer the following research questions. In a group task, does comparative performance of other workers impact the ratings that a worker receives? Does revealing previous ratings impact the future ratings that a worker receives? Does an online worker's gender affect the rating? And does a rater's gender impact the ratings they give? Most studies that have investigated demographics biases in the context of online platforms have been observational. But addressing the questions of a study using data from existing label platforms is difficult, because we can't disentangle a worker's true performance from their socially assigned rating. Therefore, to rigorously study the interaction between performance and demographics biases, we developed an experimental platform where we controlled and manipulated the true performance of a set of simulated workers, and then we conducted an experiment on the platform. We recruited participants from Amazon Mechanical Turk. Each participant, along with two simulated workers, performed a collaborative image labeling task. We introduced the simulated workers as real people from our image labeling team, so this was essentially a deception study. And at the end of the task, we asked participants to rate their teammates. Here are the mechanisms of the task. As each participant arrived on the platform, they were assigned two simulated workers. The team was then shown 5 images one at a time. For each image, the simulated workers would generate 5 tags each. The participant would then choose 3 tags from the tags that workers had generated and would submit them as the final tags for the image. We differentiated between high and low performing workers using the quality of their generated tags and the speed of the response. Low performing workers were generally slower and had some low quality tags mixed in the responses. Participants could not choose the final 3 tags until both workers had submitted all of their tags. And task instructions specified that to receive bonus, the submitted task should be of high quality and the task performed in an efficient manner, so the performance of the workers would affect the utility of the participant as well. Here, the image at the top shows that Jeremiah, who is a high-performing worker, is untagging the image while Kate, who is low-performing, is still generating tags, and the participant can't start to construct a final tag list. The image at the bottom is from another round of the task, where the participant has added 3 of Jeremiah's tags to their final tag list. So basically, the task served 2 purposes. First, to reveal the performance of workers in a natural setting and expose participants to the impact of their collaborators' high or low performance, and second, to serve as a pretext for soliciting ratings afterwards. At the completion of the task, participants were directed to this page on which they evaluated each of their coworkers. The evaluation was done in 2 parts. First, they were asked to rate workers via a conventional star rating and stating how willing they are to work with each worker in the future, and when they clicked on Submit Evaluation, we asked them how each worker could improve. We separated this question because it involved more deliberation. We also asked them to distribute a bonus of $1 between the workers. It is actually difficult to uncover nuanced biases through simulated experiments because of several factors. For example, participants don't have skin in the game, or because it might be evident what the purpose of the study is. We carefully designed our experiment around these factors by consulting prior related findings. For example, a prior study that did not find demographics biases in evaluating gig work suggests that evaluating work done for someone else may not trigger enough empathy or ownership to show evaluation bias. Guided by this hypothesis, our participants' pay was ostensibly affected by the performance of the workers that they rated afterwards. In addition, the task being collaborative provided participants with context and history, the lack of which has been suggested to underestimate workplace evaluation biases in simulated experiments. And also by pairing participants with two workers, we hope to enable them to calibrate their ratings and draw relative judgments from them. The experimental factors for study were performance and gender. We had high and low performing workers and males and females. We created 16 simulated worker profiles that represented these four experimental factors and gave each profile a picture and a name. We chose worker profile pictures from the Chicago Face database. The dataset contains measures along various face characteristics, for example, attractiveness and how prominently each face is perceived as belonging to various races. We counterbalance the profile photo dimensions other than gender. You can refer to the paper for details on this. And to counterbalance race for each gender and performance profile, we chose pictures from the four races or ethnicities of Asian, Black, Hispanic, and White. To choose worker names, we consulted New York City's dataset of popular baby names that is categorized by baby's gender and mother's ethnicity. We explored this experimental setting across three conditions to understand the impacts of social signals on ratings of digital workers, as well as their interactions with potential gender biases. In one condition, which we called no ratings, we did not display ratings given to workers by other raters. So when evaluating workers, participants were blind to how the others had rated them. In two other conditions, participants could view worker ratings both in the course of their collaboration on the task and when providing evaluations. These were the true ratings and reverse ratings conditions. Each of these two conditions consisted of 4 universes. Each universe was essentially a replication of the same study. Each universe contained a replica of the same simulated profiles dwelling in isolation from other universes. So for example, ratings of Dylan, a high-performing white male worker on our platform, in one universe were not impacted by ratings given to other Dylans in other universes. These independent universes would provide a naturalistic setting for evolution of ratings, as these profiles were rated by one participant after another, and their average rating would change immediately after each evaluation. This duplication would also allow us to account for random noise within one universe. The profiles in the true ratings and reverse ratings conditions had ratings at the onset of the universe. We set these initial ratings as the average of the ratings the profiles had received in the no ratings condition. In the true ratings condition, we displayed the actual ratings of each profile to the participants. In the reverse ratings condition, on the other hand, at the onset of the universes, we flipped the performance of our workers so that their displayed rating would not agree with their current performance. For example, in these universes, Dylan would be a low performer, but it would initially be displayed with the high ratings that he had obtained before. Now let's discuss the results. I'll be mentioning the high-level takeaways from the results, and for the numbers and the stats, I refer you to the paper. As a first check, we examined whether high and low performing simulated workers were perceived as significantly different from one another in the appropriate direction, which they were. In the no ratings condition, that is in the absence of social signals from other raters, low performers were given an average of almost 3.5, and high performers were given an average of 4.3. We had hypothesized that ratings a worker receives may be impacted by their performance relative to that of their coworker. So we examined the difference in ratings across all conditions between workers in matched performance trials, where both workers have the same performance level, and workers in unmatched performance trials, with one low-performing and one high-performing worker. We found that low-performing workers received a lower rating when paired with high performers, compared to when they were paired with a low performer. Similarly, high-performing workers received a higher rating when paired with low performers, compared to when they were paired with a high performer. This means that participants made relative judgments about paired workers. A low performer seems even worse when in direct contrast to a high performer, and vice versa. We then investigated how exposure to ratings from other raters affects the ratings that participants give. We found that displaying ratings of prior work, even when they are misaligned with the worker's current performance, that is, in the reverse ratings condition, affects their future ratings. We saw that when true ratings were shown, low performers were given lower ratings compared to when their ratings were not displayed. Also, when ratings of high performers were shown, they received higher ratings compared to when they were not displayed. When current performance did not match rating history, low performers were rated higher compared to when their actual low ratings were shown. And similarly, when current performance did not match rating history, high performers were rated lower compared to when their true high ratings were shown, so it seems like raters were taking cues from prior ratings. One important catch in all this is that this mimicry of higher ratings almost only surfaces when performance is matched, that is, when the two workers cannot be differentiated performance-wise. We also examined whether the gender of workers has an effect on the ratings that they receive, and indeed it does. Again, this bias surfaces only when there isn't a performance difference between the two workers, and it targets low performers only. We saw that low-performing male workers are given higher ratings than low-performing females. This difference in the ratings of low-performing males and females is highest in the no ratings condition, when ratings from other raters are hidden, and it becomes negligible in the reverse ratings condition, where low-performing workers who are the target of this bias are displayed with high prior ratings. We also observed that the gender of raters also affects the ratings that workers receive. This bias interacts with the gender of workers, only emerges in the ratings of low performers, similar to the biases that we saw before, and is dependent on the comparative performance between paired workers. When the performance between paired workers is the same, female raters rate low-performing male workers higher than low-performing female workers. On the other hand, when the performance between paired workers is unequal, male raters rate low-performing female workers higher than low-performing male workers. Our results contribute empirical understanding of the complex and nuanced circumstances where biases manifest. Understanding these biases is the first step towards designing platforms that counteract these biases. We saw that bias is context-dependent. When workers could not be differentiated performance-wise, two types of biases crept into their ratings: mimicry of prior ratings by raters, and bias related to gender. The mimicry of prior ratings resulted in ratings of low performers to be lower and ratings of high performers to be higher when their prior ratings were revealed, compared to when we did not show the rating history. We saw that the gender bias targets low performers only. This finding is important because low-performing workers are often most vulnerable to platform decisions. Among low performers, we saw an anti-women bias by female raters. One way platforms can perhaps eliminate these biases is by guiding their users through a list of well-defined criteria when they're asking for ratings, to help users make a distinction that is solely based on performance. When the performance difference between paired workers was noticeable, we saw that male raters gave higher ratings to low-performing females compared to low-performing males. Could this be an instance of benevolent sexism, where men feel compassion towards females and desire to protect them? Future work could investigate this issue further. In a reverse ratings condition, where the performance of workers and their ratings history did not match, we did not see mimicry of prior ratings or the gender bias. Can platforms leverage this approach as an intervention, for example by displaying a tweaked version of the worker ratings? It is, however, unclear whether it is ethical to randomly lower the ratings of high achievers to see, for example, if mimicry has contributed to their high scores. And with this, I conclude this talk. Thanks for listening.